going to discuss about confusion matrix. Myself Vikas. Brief introduction about me. I have around 5 years of experience in data science and analytics, and I have specialization in both machine learning and deep learning. And I have worked on various domains such as finance, manufacturing, retail, healthcare, and others. So today's agenda will first discuss what is machine learning. Most of you know machine learning. It will be a brief introduction. Then we will see the types like classification and regression of ML. Then we will see the performance metrics which are used in both regression and classification. Then we are going to build a confusion matrix which is used for classification. Then we will build a confusion matrix in Jupyter notebook using Python. So now let us head to this slide where I am discussing about machine learning. So what is machine learning and why ML is important? So nowadays the data generated by users is very huge that it is giving an insight to the business industry. So one who is able to understand and make a proper decision, then that business will be in a good profit compared to their competitors. So basically, machine learnings are used to analyze the data, like many companies are using, such as Facebook, Google, and Uber. So, and other thing is that machine learning is a subset of artificial intelligence, and nowadays it has emerged as a critical point of competitive difference for many firms. So this is about a brief introduction to machine learning. So now let us see what is classification and regression. As the name suggests, classification is nothing but classifying between a number of objects to which class it belongs. And regression is nothing but it is a continuous variable which predicts what is the given output for a given input. So both regression and classification comes under supervised machine learning, and both algorithms utilize labeled dataset and are used for prediction in ML. And however, how they are applied in various machine learning issues is where they diverge from one another. So basically, there is difference between to which problem statement which one to apply. And for example, regression is used in like a price, salary, age prediction, and this classification is used for like predicting true or false, spam or not, or like male or female. So for this value, we can use a classification, and the remaining we can use a regression. So now let us understand what is classification. Classification is a process of finding a function that helps in dividing the data set into classes based on different parameters. So as I said, it is about predicting the classes, n number of classes. If there are n number, then it will predict n number of classes. If there are two, it is known as a binary classification. If it is more than two, then it is belongs to n number of classification. So basically, there will be input and output. So output is defined by y and input is given by x. So for a given input, what is the output? For example, if a given input belongs to male or female, then it has to predict what is the output for that. So similarly, regression comes in handy where there is a continuous values are there. So for example, in predicting the market trends and house price prediction and many other live examples we can use for regression. So this is about classification and regression. Now let us understand better with this picture help. Okay. So classification is nothing but to predict whether this day is hot or cold. Okay. In summer, what is hot, what is cold, everyone knows that. In Fahrenheit, we are going to see the temperature. So temperature, what is the value it shows? It doesn't tell that, okay, it belongs to like winter or summer. That we have to decide based on the temperature. Okay. So what is the temperature value it gives is in Fahrenheit is known as a regression. It's a continuous value. Whereas in classification, it is a discrete value. It will classify whether this today is a hot or a cool. So this is a basic difference between classification and regression. Now understand the performance metrics and why performance metric is important. So performance metric is nothing but it is like a measuring tool. How our model efficiency is good, what is the quality, and what it can, whether we can deploy it to the server or cloud for production. So these all can be evaluated by using performance metrics. So basically, for classification and regression, we use both performance metrics, and classification is used for dataset that classifies a new data into classes or groups. And after that, it generates the class labels as output, such as yes or no, zero or spam, at 0 or 1, and so on. If it's a binary, or otherwise a number of classes also it can classify. This is about the performance metrics. And now let us understand some formulas which are used in classification matrix, which is nothing but precision, accuracy, recall, F1 score, and why and when we have to use. So basically, all this comes in the under a classification problem. In regression, there will be just a percentage value, and in classification, we can build not only accuracy, but we can, based on the problem statement, we can take a precision, recall, and F1 score. So what is accuracy? Accuracy is nothing but number of correct prediction divided by total number of predictions. So this is just like nothing but a percentage of the marks we obtain in a school or college. So what is precision? Precision is nothing but TP divided by TP plus FP. Yeah, what is TP and FP? We will see in a while. TP is nothing but true positive and false positive. So recall is nothing but TP divided by TP plus FN. That is another true positive divided by true positive plus false negative. So F1 score is nothing but it's a 2 times of precision into recall divided by precision plus recall. So why all these many formulas are required is because it is based on, since it is a classification problem, it depends uh, which problem statement, according to that, whether the accuracy is important, whether the precision is important. For example, if medical healthcare is there, at that time precision is important, because accuracy is not only the criteria. Based on precision, we can judge it. So now let us understand the performance metrics for regression. So in regression, as I told, it will be a continuous variable values. So there we will directly get the percentage value or a score. These accuracies can be measured using like MAE or MAC R square or just R square. MAE is nothing mean absolute error, and MAE is nothing, MAC is nothing but a mean squared error. So R2 score is nothing but it is a advanced version of MAE. Then adjusted R2 score is, it is next version of R2 score, where we are going to improve the accuracy, or we are going to make the model robust. So yeah, MSC is nothing but it is a summation of 1 over total n, y minus y x square, y and y is a original and y is a prediction value. So similarly, MA is nothing but 1 by n summation of mod of y minus y dash. So similarly, R square is nothing but 1 minus MSC divided by MSC model divided by baseline. So basically, these all formulas are used to calculate the accuracy or the quality of the model which we have built. Whether if the scores are satisfactory, then we are going to deploy our model. If not, then we are going to rework on our input variables. Then we will decide, okay, what is the percentage. It is just like a student obtaining percentage in a school, whether he has passed or not, whether he is eligible for going ahead for the next class or not. So this is just like a measuring values. And now let us head to this AUC and ROC curve. As I told, this TP and FN and all we will see now. TP is nothing but a true positive. FN is nothing but a false negative. FP is nothing but a false positive. So why AUC and ROC curve is required? And first of all, what is AUC and ROC curve? ROC curve is AUC is nothing but area under the curve. Means when we build n number of models, okay. So even in for one model, we will use n number of algorithms, and we want to test which one is the best one. So for example, I have built a 3 machine learning algorithms model for one problem statement. So I don't know which one is best. So I want to get an accuracy here that which gives like which gives the highest accuracy for the given algorithm. So here basically there are 3 algorithms I have used. For example, if I taken one problem statement, and I have drawn a AUC and ROC curve. Here I got 3, and I'm not able to decide which one to consider for finalizing my machine learning algorithm. So at that time, we can use this particularly for this classification, and we can draw AUC and ROC curve. When we draw AUC and ROC curve, then the curve which has a highest area under its curve, that will be known as a best predictor. So for example, here you can see this is a random classifier, and after that we did some proper training. Then it has improved better classifier. The next version is good classifier. You can see that area under this random classifier is only this much. Okay, and in better classifier it improves. Okay, and in good classifier it is much more than it is almost like a 90 plus. percentage. So this is the advantage of having AUC and ROC curve. We will come to know, okay, even if we have used n number of algorithms for a given problem statement, which one is better, that we can judge by using AUC and ROC curve. So there are typically TPR and FPR are the x-axis and y-axis which we are used for drawing AUC and ROC curve. What is a TPR is nothing but a true positive rate, and FPR is nothing but a false positive rate. TPR is nothing but TP divided by TP plus FP. TP is true positive divided by true positive plus false negative. So that is about AUC and ROC curve. Now let us understand how we are going to build a confusion matrix here. Particularly, this performance matrix are evaluated for classification as a confusion matrix, and for regression there are other like MAE, R just R square and R square. So particularly here we have to build one confusion matrix. Why it is known as a matrix? Because it is in the form of matrix X and Y. So it is known as confusion matrix. Why you can say confusion means it is like it is drawing properly what is a true and what is false for a given prediction. It is a bit confusion, so it is known as a confusion matrix. So until unless we know proper value, we are not able to get the output. So it is that's why it is named as a confusion matrix. So here I'm basically trying to cast to table for confusion matrix. So for example, this is the actual and this is a predicted. Actual is saying no and predicted is saying no. Then it is known as true negative. Okay, actual is saying yes and predicted is saying no. Then false. Why false? Because actual is yes, but predicted model is saying no. Then it is false. Why positive? Because this is a positive sentiment. So it is a positive. Here it is a negative sentiment. It is so negative. Similarly, actual is no and predicted is yes. It is a false. Okay, this is a negative. Yes is a false. Okay, and this is no is negative. Negative sentiment. So it is a negative. Similarly, in this case, actual is yes and predicted is yes. Okay, so in this kind it is matching. So in there are 100 cases, out of which, for example, 50 are true positive, 10 are false negative, remaining 15 and 15 are like whatever the amount is, that is a true negative and false positive. So like this, out of 100 cases, we are going to build a confusion matrix for classifier. Then we will come to know what is our accuracy. If it is a 50 lakh, we will come to know that my model accuracy is 50%. But this is not only that, in even the precision and recall, we can calculate. Always accuracy is not our criteria. Even 60% accuracy is enough for a problem statement. But whatever the accuracy is there, that accuracy shall hold good and precision shall be higher. For example, in medical condition, yes, we can use a precision. So this is how we are going to build a confusion matrix. We can build for any number of confusion. For example, if three classes, 3 class 3 confusion matrix we can build, and like n number of confusion matrix we can build. Okay, what it is saying, the performance matrix of the classification model also for a certain set of test data is assessed using a matrix called the confusion matrix. Only after the real values for the test data are known, it can be determined. This is nothing but we should have actual value. Then we can compare it with the predictor value. Then we can build a confusion matrix. Okay. Then actual values are the real values for the provided data. Actual is nothing but it is a data which is true. Okay. Whereas the predicted values are the values that is modified. For example, I have built a machine learning algorithm, and based on the machine learning, it is giving some prediction. So that is known as a predictor value, and the actual value which we have data from a market or whatever. So that is known as actual value. So combining these two is known as total prediction, and n is the total prediction. So now better understand with this one diagram I have taken. Okay. So as I told, this is the actual value and this is a predictor value. Here in actual it is a dog. Okay. This is a cat. Okay. In this condition, what my model is telling, dog. Okay. This is also predicting a dog. This is in a predictor condition. And in actual also, this is a dog. So this is known as true positive. Okay. Now let us see. Actual, this is a cat. You can see this is a cat. But the model is telling that this is a dog. Okay. So this is, since predicted is a positive, but this is not a valid one. So it is a false positive. Okay. So now let us see now next. What it is saying, predict this supposed to be a dog, but it shows a cat. Okay. So this is a negative, but this is a false. So that's why it's called as false negative. Similarly, supposed to be it is actually is a cat, and my model also predicts a cat. So that at that condition, this is known as a true negative. Okay. So what is true negative? Model has given a prediction no, and the real or actual value was also no. Okay, that is known as a true negative. In a true positive, the model has predicted yes, and the actual value was also true. So that is yes, both side yes. That is known as true positive. False positive means the model has predicted yes, but the actual value is no. The model is yes, but in real it is no. This is known as false positive. Also, this is known as a type 1 error. Okay. And another one is known as a false negative. In this condition, the model has predicted no, but the actual value is yes. So this is known as type 2 error. So there are two types of error in confusion matrix. You have to remember. One is type 1 error and type 2 error. Type 1 is nothing but false positive. Type 2 error is for false negative. And true positive and true negative holds good in case of there are no errors. Okay. So this is one basic imagery example I have taken. So now let us build one confusion matrix using Jupyter Notebook in Python. Okay, iris flower, where we have to predict sepal length and petal length. So this data set we can directly download from sklearn. Okay, this I have downloaded from sklearn. We can import it as a sklearn data set. Import load iris. So when you load the data set, so basically it has four targets. One is setosa, versicolor, and virginica. Sorry, there are three targets. Okay, so it has to predict, and the features it has a four. That is nothing but sepal length and petal width and petal length. Okay. So this is a standard data frame. I am reading it. Okay, which using pandas library. Okay, this I have imported here pandas as a PD. So this is a way to read the data frame. Okay, then I wanted to know what are the target value. Okay, then data frame or target is not I did target. And when I did, there are three classes. So first four is showing this as a 0, and next for 50 to 100 it is showing as a 1. I mean to say second target, and remaining is showing it as a third target. Okay. So what I have did is I have here just cross checked with what is 0 means setosa. Like this I have done. 1 means versicolor. So like this I have built the model. And here I am trying to just do some analysis of this flower dataset. Okay, for that I am using a matplotlib library just to visualize how there is a relation between sepal length and sepal width. Okay, so once I done with the data preprocessing and visualization, then I will try to build a model. For that, I have to split the dataset in test and train dataset. Okay, so out of which I have taken 20% for test size, and remaining I have taken for training. So you can say total out of 150, I have taken 120 for training and 30 for a testing. So what I did here is I have taken a KNN algorithm in this example to build our model. So how to build a model that you can import a KNN neighbor classifier. This is a classification problem. So I imported K neighbor classifier from sklearn neighbors. Okay. So then after that, I have fitted a model using X10 and Y. So once I did the model, then I got a accuracy of the test and Y test. What I got is 96%. Okay. So I did some random prediction. Then for the given value, I got a array as 0. Okay. So now I just want to know how well is my model. So here we are going to build a confusion matrix. So how to draw a confusion matrix? So for that we have to import confusion matrix from sklearn.matrix. Okay, you have to type this as from sklearn.matrix import confusion matrix. Okay, then for that we have to change the y predicted is equal to knn predict underscore x of test. Okay, so confusion matrix I have renamed it as a confusion matrix y test, and it takes two variable y test and y pred. Okay, y pred is from here. Okay, y test is whatever the test outcome is. Okay, so after building this, once I run what is CM, then I am going to get the value here. Okay, 112106. Okay, so this is a real confusion matrix how it looks. Okay, this is a 3x3 confusion matrix I have built. Okay, as I told, we can build any number of confusion matrix based on the problem statement. Okay, so for better visualization, I am using matplotlib to understand how exactly the confusion matrix is looking like. Okay, So, so you can see this is a true value and this is a predicted value. Okay, when model is saying 0, okay, 0 flower, and it is showing 11. Okay, in that condition is also there are 0 numbers. Okay, so this is how, and in true condition there are 12 with true condition. Okay, in predicted condition 1 there are, out of which 12 are there, and out of which again in truth there is 1, and second flower category, this is a predicted one, this is a true one. So like this we have to build a confusion matrix. Okay, so thereafter, once we build this confusion matrix, then we can understand the accuracy and what are the score. So as I told, precision, recall, F1 score, it depends on based on the problem statement. So we have achieved accuracy of 90%, 95%, and this recall is 97%. So basically, we are interested in building a confusion matrix. So this is how we can build a simple confusion matrix using sklearn matrix library. So this is how we have to build a confusion matrix. Then thereafter the confusion matrix, once we build, we can get a exercise. Thank you all. Thank you for joining.